What we are doing today is we are learning a couple more of our identities. So we've already talked about our Pythagorean identities, we talked about our co-function identities, and we talked about our odd and even identities. What we're looking at today is our sum and difference identities. Now, if we take a look at the very first thing here, it says let u be equal to pi and v be pi over 2, and we're finding sine u plus v. So if we start off u plus v, we're going to do pi plus pi over 2. And in this case, pi and pi over 2, when you combine those, you get 3 pi over 2. And if you think about your unit circle, I'm just going to sketch one here. Unit circle is 3 pi over 2 is going to take you to here. And so your sine value there, or your y value there, is negative 1. Now, if you take a look at the second one, if you do sine of pi plus the sine of pi over 2, sine of pi, we take a look at our unit circle, is, sorry about that, is going to be right here, which means that sine value is 0. Pi over 2 is just up at the top there, so that's going to be a 1. 0 plus 1 is 1. And so we take a look at these two things here, we recognize that those are not equal. If we take a look over at the cosine side, u is 0, v is 2 pi. So cosine 0 plus 2 pi. If we think about 0 plus 2 pi, that is just 2 pi. So if you go 2 pi around your unit circle, your x value in this case, since we're looking at cosine, is 1. If we take a look at the one on the right and split it up, cosine of 0 plus cosine of 2 pi, each one of those will give an output of 1, and 1 plus 1 is 2. And so again, when we look at these, we recognize that these are not equal. So all that to say this, if you look at these, for both sine and cosine, I'll just write it for sine though, this, you can't just split up addition. So what I mean by that is if you would take a look, that does not equal sine of u plus sine of v. And then the same thing for cosine. And what we did in the blue is a specific example to show that those are not equal. So what you need in your back pocket to be able to use are these cosine of a sum or difference and sine of a sum or difference identities. So this is what you're looking at. So cosine of u plus or minus v equals cosine u times cosine v. And then I'm going to write minus plus, and we'll talk about what that means in just a second. And then sine u times sine v. Now if you look here, this is originally plus minus, this is originally minus plus. So what that means is when you rewrite the right-hand side, you're going to have a sign change. So if it was originally addition, it becomes subtraction. If it was originally subtraction, it becomes addition. If you look at the sine one, you have sine of u plus or minus v equals sine u times cosine v. This one is plus or minus, so notice it's the same as cosine u times sine v. And so again, since these are the same here and here, that just means that you keep the sign, so no sign changes. Or you could say same sign, if that makes sense to you. Okay? So when you look at this, we're going to jump into some examples using this. Now, the math behind it gets a little bit ugly because you're going to have some radicals in here. But one of the things that I always encourage people to do, especially early on, especially since fractions are not always our strong point, is I would recommend that people think about your radians. So our radians that are key in our unit circle are pi over 6, pi over 4, and pi over 3. If we want to change those to have a common denominator to help us kind of think about those as a whole, 6, 4, and 3, the common denominator would be 12. So that means that that's equivalent to 2 pi over 12, 3 pi over 12, and 4 pi over 12. Okay? So we're just going to kind of hold on to that. We're going to use that here in 1 minute. If you notice, our question for part A isn't in radians, so we don't need to use it for that. But if we think about our key degrees in our unit circle, our key degrees are 30, 45, 30, 45, and 60. So we can split cosine up into 30 and 45. So we want to say, okay, I don't know what cosine 75 is, but I do know what cosine 30 and cosine 45 are. So that's going to be the equivalent. And now we're going to go back to using this cosine of a sum or difference. Okay, so notice that we're adding, so we're going to use this here, this first one. So we're going to go ahead and we're going to say, all right, we're going to have cosine 30. Actually, I'm going to take the parentheses out so we don't get confused. Cosine 30 times cosine 45. So I'm just using that identity and I'm substituting. Minus, okay, again, when we go back to this, cosine is the one that has the sign change. So we have to change our sign. What was originally addition becomes subtraction. And then sine 30 times sine 45. And now we can use our unit circle to figure out our pieces. So what I mean by that is cosine 30, if you look at your unit circle, is root 3 over 2. Cosine 45 is root 2 over 2. Sine 30 is going to give us 1/2. And then sine 45 is going to give us root 2 over 2. And so when we simplify this, we're just going to simplify one thing at a time. That's going to give us, when we multiply fractions, we multiply straight across. So root 3 times root 2 gives us root 6. 2 times 2 gives us 4. When we look at this one, we would get root 2 minus root 2 over, again, 2 times 2 is 4. So we can simplify that to be root 6 minus root 2 all over 4. And that is our answer for the cosine of 75 to figure out our exact value. All right, so if we take a look at part B is very similar. The only difference is it's in radians. So we look at 7 pi over 12. 7 pi over 12 is going to be a combination of those two. So 3 pi and 4 pi over 12. So what we can split this into is sine, and instead of thinking about it over 12 now, let's go ahead and put it back in the ones we're familiar with. So sine of pi over 4 plus pi over 3. And then when we can go ahead and take, and again, I'm going to come back to here, I'm going to be using the bottom one this time. I'm going to be using the sine one. And notice this one has no sign change. So I'm going to go ahead and substitute. So I have sine of the first one, so pi over 4, times cosine of the second, pi over 3. It was originally plus, so it stays plus. And then we have cosine of the first times sine of the second. So again, I'm just using that identity, I'm just substituting. And now I can go ahead and figure out my values at those points. So pi over 4, sine pi over 4 is root 2 over 2. Cosine pi over 3, 1/2. Cosine pi over 4 is also root 2 over 2. And then sine pi over 3 is root 3 over 2. And now I can simplify again. So when I look here, I have root 2 on the top, 4 on the bottom. The second one is going to give me root 6 on the top, 4 on the bottom. So that simplifies to be root 2 plus root 6 all over 4. Okay? Now, tangent gets a little ugly, because tangent, as we know, is sine over cosine. So when we take a look at this, this is going to take up some room, so I'm just going to warn you, you want to write small. So this is going to be sine over cosine, and 15 is going to be 45 minus 30. And again, 45 minus 30. And so when we look at this, we can split this up. So we're going to focus just on the top part right now, the sine. Again, sine is going to keep our sign, no pun intended here. So we have sine of the first, so sine of 45, times cosine of the second one. Keep the sign, so we're going to keep that subtraction. Cosine of the first, sine of the second. All over, and now we're going to focus on the bottom. So the cosine, we have cosine 45 times cosine of the second. And then our sign changes, so it's going to change to a plus. Sine 45, sine 30. Okay? Now, what we're going to do is just a series of substitutions based on what we know from our unit circle. So sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Minus cosine 45, so I'm just here next, root 2 over 2. Now I'm here, times 1/2. All over, and now I'm going across the bottom. So cosine root 2 over 2, cosine 30 is going to be root 3 over 2, and plus sine 45, root 2 over 2, sine 30 is going to give us 1/2. And so now we can go ahead and simplify. So across the top, again, we see that root 6 over 4 minus root 2 over 4. Okay, you're going to have some consistency, so don't second guess that. The bottom is going to be root 6 over 4 plus, and then you have root 2 over 4. Now, there's several different ways that you could go about doing this. One of the things that I would suggest to start is you have fractions within fractions. So we've talked about this recently, that the way to go about getting rid of that is multiply the top and the bottom by that denominator. So if I multiply everything by by 4 over 4, that's going to cancel out all of these 4's. Okay, so I end up with root 6 minus root 2 over root 6 plus root 2. And then when you think back to algebra 2, you have radicals in the bottom. You can't have those. So to get rid of them, we're going to multiply by what's called a conjugate. Okay, so the conjugate is just the bottom, but an opposite sign. So for example, I'm going to have root 6 and root 2, but instead of plus, it's going to be minus. And we're going to do that to the top and the bottom. We'll see why in just 1 second. So stick with me. We're almost done, believe it or not. All right, so we're going to go ahead and think about these as binomials, and then we're going to FOIL. So root 6 times root 6 here is a 6. Root 6 times negative root 2 is going to give us minus root 12. The inside is going to be another negative root 12. And then the last are going to be a plus 2. The bottoms, the first are going to give us a 6. The outers and the inners cancel. And then the last are going to give us minus 2 on the home stretch. Okay? Then we just do a matter of simplifying. So I'm going to bring this down here. I'm going to give myself a little bit more room. So we have 6 plus 2 is going to give us 8. We have 2 of those root 12s. 6 minus 2 is 4. And then the only other thing is here, this root 12 can be simplified to be 2 root 3. So that's going to be 8 minus 4 root 3 over 4. And then I can take out a factor of 4 from everything. So I end up with 2 minus root 3. That's a lot, okay? So the biggest thing is making sure that you write down your identity correctly, making sure you plug in the correct values, and then from there, it's back to algebra 2 mindset as far as simplifying with those radicals, okay? Now, the beautiful thing is that's one way to go about tangent. There is another way to go about tangent, and that's what we're going to put here in this box. So I'm going to put a big or, okay? And it's going to make things a little bit cleaner, not entirely, but if you have tangent u plus or minus v, it's going to be equal to tangent of u, and then plus or minus, notice that sign stays the same on top, and then all over, and then 1 minus plus tangent u, tangent v. Okay, so here it stays the same, and down here it changes. So if it was originally plus, it's going to change to minus on the bottom. So let's take a look at one more. This is our last one that we're going to do. We're going to do a couple examples to start off class tomorrow with some of these things, so that way we can hopefully clear up some questions if you have them. So first off, if you look at tangent of 11 pi over 12, if we look at these combinations up here to figure out what 11 pi over 12 is, you see that there's really no obvious. So like 2 plus 3 is 5, 3 plus 4 is 7. But if you extend your thinking just a little bit, 2 pi over 3 is going to be equivalent to 8 pi over 12. And so now I can use these two to get us to 11 pi over 12. So we take a look at this tangent. We've got tangent of pi over 4 plus 2 pi over 3. And what we're going to use for this one, instead of using what we did on the left, the sine over cosine, I'm just going to practice using what we did here in this box. So if we look at this, we have tangent of u on top, so tangent of pi over 4. Notice we keep the sign, so it's in the numerator, so it's going to stay plus. And then tangent 2 pi over 3. And then all over 1, and then again, your sign changes in the bottom, so it turns to minus. Tangent of pi over 4 times tangent of 2 pi over 3. Okay? Now, one of the things that I just want to kind of write off to the side is if you look at your unit circle, tangent of pi over 4, it's going going to be root 2 over 2 divided by root 2 over 2. So that's going to simplify to be 1. And then your tangent of 2 pi over 3, that's going to simplify to be root 3. So just as a refresher, tangent is going to be your y value divided by your x value, and then you have to simplify. Now the reason I put this here kind of as a subset is now we can just substitute things in. All right, so when we look at our problem, tangent of pi over 4 is 1, 2 pi over 3 is root 3. Down across the bottom we have 1 minus, and then we have 1 times root 3, so that turns into 1 plus root 3 over 1 minus root 3. And then again, we just have to rationalize our denominator by multiplying by the conjugate. So we're going to use the bottom, but change our sign. And again, we're multiplying binomials, so think about these having parentheses. We're going to FOIL, so across the top, 1 and 1 gives us 1, root 3, and another root 3 gives us 2 root 3. And then the last are going to give us 3 all over. First are going to be 1, outers and inners will cancel. And then the last will be minus 3, so we can simplify to be 4 plus 2 root 3 on the top, divided by negative 2, which then we can go ahead and take a negative 2 out of everything, and you end up with negative 2 minus 2 root 3. And that's going to be our answer. Okay, so this is a lot. Like I'm not going to try to tell you that it's not. When you look at these, it's like, holy cow. But the big thing is take it one step at a time. Make sure you're plugging things in correctly into your identities. Make sure that you don't forget your unit circle that we've studied so much in the past. If you need to, have that unit circle beside you. Again, to start the next class, we are going to do a couple of these examples on the back together. So hopefully that will help kind of clear some things up if you do have any questions. Let me know. Thanks.